everybody, welcome to the channel. Today we have a pretty good problem, and it's a classic. So let's quickly go ahead and read the problem statement for you guys, right? So it's called daily temperatures, right? So this is given an array of integers called temperatures, right? Represents the daily temperatures. Return an array answer such that the answer of I is the number of days you have to wait after the if day to get a warmer temperature, right? So if there is no future day for which this is possible, keep the answer of I equal to 0 instead. Okay, so it's a pretty good problem statement, as you guys can see, right? So let's go through a couple of examples so you can kind of solidify the ask, right? So they said that we'll be given this temperature array, and this temperature array, right, represents the temperatures on each day, right? So for day 0, the temperature is 73, and day 1 is 74, right? Day 2, right, 75, so on and so forth, right? And our job, right, is to return the temperature, then the temperature, how many days you had to wait until we saw a warmer day than that temperature, right? So for example, right, for day 0, we had to wait 1 day, right, to see a warmer day, which is well, we end up putting 1 at that particular day, right? Day 0, we had to wait 1 day. For day 2, for day 1, right, you had to wait 1 day to 1 day, which is 75, right? 74, 75, right? You had to wait 1 day. Then for 75, you had to wait a couple days, right? Because the next day was a little bit colder. It got even colder, still colder than 75, and then boom, right there, we saw that it had to wait 4 days. 1, 2, 3, 4 days. We end up putting 4. So it's kind of how it is being done, right? And it's for this day, right? It checks how many days it has to wait, and this is colder, and this is the one that's slightly warmer, right? So we end up saying it had to wait 2 days. So let's count the task here, right? For each day, find the next day, right? Find how many days you had to wait until we saw a warmer day, right? So we can't be for 76, right? Right? There was no other day that was like greater than it, right? Just like for 73, which is a good case, right? 73, there's no warmer next days, right? But that's to its right? Because the days, they go linearly, right? Can't go back in time, right? So for 73, can't go say, 76 warmer. No, that came before it, right? So it doesn't count. That's why we end up putting 0 as the answer, because it says once we don't find an answer, we need to return 0, right? It's kind of the main thing here, okay? So how can we go ahead and solve this problem, guys, right? What's kind of the intuitive approach, right? So the intuitive approach is the intuitive approach is to just for each day, right? As I was doing it, is to find the next warmer day as we go along, right? So for 73, we start from there and then loop through the remaining days in the array, right? Try to find a day that's warmer, right? If we end up finding a day that's warmer, we stop and then we record the distance of the days, right? Okay, we do the same thing for 74. Boom, loop for the remaining, trying to find one, right? And it should work. 75 does the same thing, right? Data output, trying to find it, right? So it would go from 71, 69, nope, 62, nope, 76, yes. All right, let me record that information right there. Okay, and that's my answer. So you can see we do this for every single day, right? So this one would work, right? But you can imagine, so the edge case, like the worst type of worst case scenarios, right? We have this type of array, right? For each day, we end up we go so like we loop through the rest of the array, try to find a warmer day than that particular day, right? We find nothing, right? We go again, we find nothing, right? And we end up doing work over and over, right? A lot of wasted effort. We loop over the same days over and over again, right? And then every time we go to end the array, we come empty-handed, right? Because there's no warmer days, right? Because of this particular scenario, how it's structured, right? The days are getting colder, right? So there's no warmer days. So this approach would be, you can already tell it's kind of a nested for loop. The nested for loop is not going to cut it. It's going to give us a n squared time complexity, right? And most likely going to ask us to really improve it, right? In interview settings. So we're gonna have to come up with a better approach. Okay. So what is the better approach? So yeah, the n squared won't be good, right? So maybe we're gonna have to switch, right? So normally when we have those kind of quadratic time complexity, right, we normally need to introduce some sort of a memory, right, to kind of help us to keep state so that we don't, forget numbers that we've already processed, right? So memory helps us to reduce the time complexity drastically, right? From n squared to a linear thing, right? normally memory helps, right? So how can we do it, guys, right? Since we're looping over and over, is there a way we can loop once and store some metadata somewhere? So maybe we might need to kind of switch our thinking a little bit, right? To for a particular day, right? Instead of trying to forecast, right? When is the next warmer day for it, right? We can kind of store it in we can kind of store that particular day, right? In some sort of temporary data structure, right? Since we're looping linearly, right? From left to right, okay? We can store temporarily, right? Store the numbers, right? As we go along, right? In a temporary data structure, right? And we can kind of visualize this temporary data structure as some sort of a waiting area, right? For items, right? For days that need to be resolved, right? So since for that particular day, right? We don't know the, like if there exists a day that's warmer than it, right? We don't know yet, right? But we're going to put in that structure. As soon as we encounter a day that's pretty much that's warmer than it, right? We can mark it as resolved by removing it from the data structure that we end up using, right? And then get the answer for it, right? By getting the distance of how far is that day that's warmer, and then its current day, right? And then we get the result, right? So how it would work, we would just put the item in the waiting area, right? Just waiting, right? And then we will loop from left to right. Okay. And the current temperature now, right, is so we want to the future day, right, which is 60. And every time we're asking 60 greater than the item that's in our list, right? If it's not greater, right, then we know this item was not able to help resolve 90's answer, right, which is it has to be warmer, right? Since it can't help, then it goes as well. We push it as well into the waiting area along with 90, right? Right. So we always add it to the end, right? And you'll see why it's going to be useful, right? And then we go on to the next day, right, which is 50. And we see that it's 50 greater than the last item, right? Because that's the coldest day, right? And that's what I'm comparing it with, right? Because I don't even need to compare 50 with 90, right? Because if this particular day was warmer than 90, then it would have kicked 90 out, right? And it would have been the only person, right? So I only need to check the thing that's at the last item, right? And that's the coldest day in the waiting area, right? And that's the coldest day in the waiting area. Then I just need to, so for each day, it just needs to check with that thing that's waiting at the coldest one, right? Since it can't help, right? It joins the list as well, right? And now it's the coldest day, right? Because it could not kick out any of the items. It cannot resolve any of the items in the list. Okay. So we put 50. And then we go on to the next one, right? Which is day 0, day 1, day 2, day 3. We check 30. Case 30 warmer than the coldest day in our waiting area. No, it's not. Therefore, it joins the waiting list as well, right? So the answer right now would be all 0, right? Because there was no warmer day, right? Right. So let's say now we end up adding a 100, right? So let's make it clear for you guys. Waiting room. Okay. Let's say now we get a warmer day, right? As soon as we get the warmer day, 100. Okay. We get a warmer day, 100, right? So 100 is going to check with the coldest day and the waiting area, right? Which is 30. Okay. Then since 100 is warmer than 30, right? Then it can say, all right, cool. I can resolve 30's answer, which is the warmest day. They had to wait, right? They had to wait 1 day essentially, right? Which is 1 right there. Okay. Then it kicks 30 out because this day has been resolved, right? On the answer board, right? And then 100 is checks with the second coolest day, right? Oh, it is still greater, right? So answer how many days you have to wait. You have to wait 2 days, right? Then it kicks it out. There's no more waiting, right? And then we see is 100, right? Greater than 60. Yes, it still is, right? Then we kick 60 out because that's the next coolest day, right? You have to wait 3 days. Okay. Still, right? And then the waiting area, 90, still greater, right? You have to wait 4 days, guys, right? And that's how we would return the result to be that way, right? See how many days they have to wait to find the coldest day, right? See how the structure of the waiting room area, right? And you see that it was in a decreasing manner, right? And also we were checking every time for the last element that we put into our data structure, right? Okay. So this particular pattern that we just did, that we just went through, right, is called the monotonic stack, guys, right? This is a very classic technique to really master, right? Because the way that we're adding it, right, is that the orders are not monotonically decreasing, right? And we also check the last element we put out, right? So it's called a monostack, right? Right. If this question was called if we're trying to find the next colder day, right, then the stack would have been monotonically increasing, right? So it's kind of the same kind of concept, right? Because if there's no answer for a particular day, right, we just make it join the rest of the line in the waiting room, hoping to find an answer in the future, right? And that's why when we don't find an answer, right, we end up, because we add the colder days, right, into the waiting area, into the stack, right, we end up forming a like a stack, like a monotonic stack, right? Monotonically decreasing stack, because we keep adding colder days to it, waiting for an answer for the future, because there's nothing there, right? So I think the code will really help to drive the point home. So let's quickly go ahead and do that. Yeah, guys, the code will be very simple. So we said we're going to use a stack data structure. We call integer. Okay. Let's call it unresolved days, right? Okay. And what am I going to do next is to simply have our output results res new int of size temperature. Let's call it temps. Right, temps that length. Okay. So we got output result now. We will do a linear loop through so let's call it for day 0, right? Because that's the first day. Day is less than temps that length. Day plus plus, right? So the day that we're looking through, okay? And for each day that we set that, we'll be adding them to the unresolved days, right? The unresolved days, we just go ahead and add to it. So we add that particular day. Okay. So now this is where the magic happens here, guys, right? We need to see if for that particular day, right? Let's call it int third day. It would be unresolved. No, it's good. So for that particular day, what we need to do is to check, is the stack empty, right? Is the unresolved days empty? Because if it's not empty, right, then I can check for that particular day, right? For that particular day. Okay. Is it that particular day, right? So since we're storing, right, because in the unresolved days, right, we're adding the day itself, right? So the index of that day, right? And that'll be useful so that we can calculate the distance between those two indexes, right, that we're on. So for the day 0, right, there's nothing in the unresolved days because there's nothing there yet. We just put it there. Then we go on to day 1, stack it. So the unresolved day is not empty. And then what we end up doing is a couple checks, guys, right? The check will be in the temperatures thing, right, which we put for that particular day, right? The temperature at that particular day, right? If it's greater than the unresolved day, that's the last one that we put up, which is the coldest day, right? When we can get the coldest day by doing that peak, right? And since this would have compared only the this would have compared only the index, right? So we don't want only an index, we want the actual value here, the value at that particular day, right? That particular coldest day, guys. Okay. So this compares with the day, right? At index at day 1, right? Compared on day 1, is it greater than the item at, which is the 0 that we put, right? At index 073, right? It is greater. Since it is, we just go ahead and take it out. So previous day, instead of doing peak, we'll be doing, we actually take it out. And then for that, we put for that answer, right, at that previous day, because that's where that day is, right? Since we found an answer for it. Okay. The answer for it is the current day, right? The current day that we're on minus the previous day, right? The differential is the amount of days we had to wait. And then we do this for every day, guys, right? And then after that, we return the result. Okay. So it looks good to me. We created our result days pile, right? To the pretty much the waiting room area, right? And we add them one by one. We start with the first day we added there, and then we check is that empty. We check the current day's temperature versus the temperature of the coldest day, because which would be the last one we did. Because I showed you in the example, right? Which we in the waiting room area, the coldest day is always at the last one we've added into the waiting area. It's always the coldest day, because if it was warmer than any of the days, it would have kicked them out. Okay, that's kind of the thinking here. And if we end up in this stretch where all the days are getting colder, right, then the waiting area would conveniently be in the sorted manner of warmer to colder, right? So that's how we end up with the monotonically decreasing sequence, right? Which is and then the stack, because of the last one helps us there, right? So it's kind of the thinking here. That's for us if we these small test cases, guys, right? Yeah, sorry guys, I had to put pop. I'm thinking of Q's. Did it pop Q problems? Okay, it looks good to me as estimate. Also, guys, we pass all the test cases. If you guys found value, guys, so the thought process in the comment section. If you guys are new here, subscribe, because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.